Sorry about that, I just missed something here. Okay, so again, we're looking at, just to recap, we're looking at electron and charge. Okay, and here we have atoms. Okay, to decide what makes a good conductor or insulator, we have to look at what it is made of. Orbiting electrons, that's the nucleus of our atom, and that's and these are the neutrons, protons. Okay. Now everything around us is made up of atoms. An atom is made up of a number of different particles: electrons, protons, and neutrons. Now the center of the atom is the nucleus. The nucleus contains a number of protons and the same number of neutrons. Now again, when you come to look at this, remember you're looking for the video in regards to electron. Let me just make sure I've got it. Electrons and charge. Okay, that's what the video you'll be looking for: electrons and charge. I repeat it again: electrons and charge. Okay, that's the video which will relate to this verbal exposition. Now atoms. Protons have a positive electrical charge, as we can see from the previous diagram. Electrons have a negative electrical charge. The electrons are held in their orbit by the attraction that each of the electrical charges has for each other. Protons attract electrons. Okay. Well, let's look at this now. Maximum electrons in each shell. Okay. Maximum number of electrons in each shell is capable of holding. Okay. So with the outer shell, you can see that it holds a 32. And again, with respect to the nucleus, the inner shell, as you get closer, it holds 18. Now the electrons are held in their orbit by the attraction that each electrical charge has for one another. The distance away from the nucleus varies according to the energy the electrons have. Electrons orbit in levels or shells that are given labels K, L, M, and N. There is a set number of electrons that inhabit each level. You can see that N holds the largest number of electrons. The further away you are from the nucleus, the more electrons you seem to be able to have within that shell. Okay. Now an atom of copper. So all we're doing now is taking an atom of copper as to examine why copper is such a good conductor. Orbiting electrons, shells, okay? Number of protons in the nucleus is 29, okay? Now here in the outer one you only have one. Okay, as you get closer you have more. Okay. You have more orbiting electrons. Okay. As you get closer, so you can see that there's 29 number of protons in the nucleus is 29 protons in the nucleus. Okay. And this is just looking at one atom of copper. Okay. So we have a lot of orbiting electrons in copper. Now, atom of copper. Now, electrons and protons have electrical charge, and if there becomes an imbalance between the two, the atom becomes electrically charged. It is then described as a positive or negative ion. When an atom has energy applied to it, it will either gain or lose an electron. This happens when there was only one or two electrons orbiting the outer shell, as we saw in the copper atom. It is easy for small amounts of energy to displace these electrons. This is what makes copper a good conductor, by easy displacement of the electrons. Now let's look at an atom of helium. And here orbiting electrons, K shell, number of protons in the nucleus is 2, an atom of helium, okay? Now, helium has a full outer shell and is therefore very stable, so it is difficult for it to react when energy is applied to it. This makes it a good insulator. When electrons form part of a complete shell, as with the helium, they are said to be bonded electrons. When the shell is not full, as with the copper, the electrons are called free electrons. Okay? Now, current flow. Electricity is considered to be a flow of electrons. Atoms, electrons, and protons are very important in understanding how and why electricity works. When a voltage is applied to a conductor, the electrons are supplied with energy. This energy forces electrons to move out of one orbit of an atom and attach itself to the orbit of another neighboring atom. This continues along the conductor. This flow of electrons then becomes the current or current flow. So you can see that the movement of electrons it becomes the current flow in our conductor. Okay, and that conductor, being a good conductor, is copper. Now, current flow, section of conductor, example copper. Now, electron flow. Now, electron flows from negative to positive. Okay, and this is showing conventional current flow, but electron flow, you can see it here. Okay, it's flowing that way. Okay, electron flow. Now this direction indicates conventional current flow, okay, but our current or electrons actually flows from negative to positive. For the current to flow, there must be a complete circuit, a force applied to drive the electrons around the circuit, okay, and that is our EMF, electromotive force. Now we look at current flow, okay. For current to flow, there must be a source of energy, a generator, etc., a load, which could be a lamp, etc., a means of transmitting wires, etc. And this is simply our circuit here that shows you that. Okay. Okay. Now move back a bit, pan back a bit. The direction of the current has two terms. Conventional current flow, which starts at the positive terminal, flows around the circuit and returns to the negative terminal. Electron flow, which is a flow of electrons, meaning that the current actually flows from the negative to the positive terminal. Current. Current is the rate at which electricity flows around a circuit. Unit is amperes, symbol is I. To measure electricity, counting the number of electrons would be difficult. Well, nigh impossible. The unit of electrical energy quantity is a coulomb. Unit is coulomb C, symbol is Q. A coulomb is defined as the quantity of electricity passing a certain point in a circuit when a current of 1 ampere is maintained for 1 second. So again here we're using coulombs, the symbol Q, to indicate the quantity of electricity that will pass through at any one point. For 1 ampere is maintained for 1 second. That is some measurement. Here now, measuring current. The equation for measuring current flow is Q equals I times T, or I times T, where Q equals quantity of electricity in coulombs, I equals current in amperes, and T equals times in seconds. Okay. Now I hope you found this useful. Okay. And I will leave you to this. Now remember that you will need to look at the Electrons and Charge video. I repeat, the Electrons and Charge video, session 1 basically. Okay. And again here, I hope you found this useful, and have a good day. Bye bye.